Hello, and welcome to another Portworx demo. My name is Bhavin Shah, and in this demonstration, we are going to talk about how you can use Portworx Data Services to deploy a simple Postgres database on your Red Hat OpenShift cluster. PostgreSQL is just one of the different data services that PDS supports out of the box. So when you log into the PDS dashboard, you will see a catalog of different data services that are supported by PDS. And on the other side, from an infrastructure perspective, Red Hat OpenShift is just one of the Kubernetes distributions that is supported by PDS. You can use PDS to deploy the same databases or different databases on different distributions like Amazon EKS, Vanilla Kubernetes, Microsoft Azure AKS, and so on. Let's see how easy it is to perform the day zero deployment of Postgres using PDS. So I didn't have to, as a developer, I don't know how to deploy Postgres on Kubernetes. And with PDS, I don't have to learn how to deploy Postgres on Kubernetes. Instead of having to go through the different options that are available on the operator hub, I can just come to PDS, select my PostgreSQL as the data service or database that I want to deploy, select the version of Postgres that I want to run. Let's say I want to run the latest and greatest, which is 14.4. That's supported with PDS. Next step is giving this Postgres instance a name. So let's just call it demodb-postgres as the name of our deployment. At this point, you can select your target cluster. So since I have access to only one OpenShift cluster, that's what I see. But this dropdown will automatically or dynamically update to show you a list of different Kubernetes distributions that you have and Kubernetes clusters that you have access to. Let's select OpenShift cluster. And then again, dynamically, we update the list of different namespaces that are available for developers to use to deploy this database instance. Since this is a Postgres deployment, we'll just select the Postgres-demo namespace, and I do want PDS to deploy that internal load balancers for my Postgres pods. At this point, there are a couple of additional configuration parameters you can select from the drop-down menus. The first one is application configuration template. Application configuration templates are a way for developers to provide or pass runtime or parameters or provision time parameters for the database deployment. So out of the box, PDS comes with a couple called default and custom. And if you click on show details, you will see what the default application configuration template looks like. Default just creates a Postgres database and calls it PDS. If I select custom, I can configure that value. So I'll call it DemoDB as the name of my Postgres database. Again, this is customizable. If an administrator in your organization, or even if the developer has admin privileges for PDS, they can create more application configuration templates and allow to configure additional things like the username and other Postgres parameters that can be configured at runtime. Once the application configuration template has been selected, the next thing that you can select is the resource setting template. And this is where you select things like the size of the pods. So the resource quotas and limits for the application pods or the Postgres pods that are getting deployed. So if I select the small one, that basically means that each pod will have a minimum or a quota of 1 CPU and a maximum or a limit of 2 CPUs. Same with memory, 2 gigs to 4 gigs. And then each pod will be provisioned with a 100 gig persistent volume from on the OpenShift cluster. Next, I can select the number of nodes I want. Since this is Postgres, I do want 3 with a read replica. And then once all of that looks good, I can select storage options. So here, by default, I have a couple of storage options, and I can select volume replication, best effort spread, or force spread. These are complicated parameters that PDS abstracts for the user. So at this point, once you select any option, PDS understands how Kubernetes storage classes work and automatically configures a new storage class for this Postgres deployment. And there are certain things that we automate for the users. So things like IO profile that best suits the performance expectations for Postgres, all of that is configured under the covers. Here, using the interface, you can select the replication factor and the file system that you want. So XFS is the file system and a replication factor of 2. So each persistent volume will have 2 replicas spread across my OpenShift cluster. And then optionally, depending on whether you are deploying this Postgres instance for test dev reasons or whether you are deploying this for a production application, you can optionally choose to select backups. So you can, by default, you can do a full hourly backup, a full daily backup, or a full weekly backup. And again, if you don't configure something today or at day 0, you can always go back and update this parameter and enable scheduled backups. Again, if you want to take the advanced settings look, administrators or developers who have admin access to PDS can go ahead and configure additional schedule policies for that can be available in this drop-down menu. Let's just keep it simple. Let's select the full hourly backup. And once I select that I want backups to be enabled, it shows me a list of different backup targets that are available to me. I'll just select the backup bucket as the target that my administrator has configured for me. It can be any S3 compatible backup repository. Once I select the backup target, I can just hit deploy, and PDS will talk to the PDS agent that's running on the OpenShift cluster and automate the entire deployment for me. This involves configuring a few different things. This involves configuring the storage class, deploying the 100 gig persistent volumes per replica that I have configured, and then deploying a stateful set object for the PostgreSQL instance. And this stateful set basically deploys individual pods as replicas for the stateful set, and it configures service endpoints for my Postgres instance. So while the UI is going through the deployment, let's go to our OpenShift cluster and see this in real time. So we can use OC get commands or kubectl get commands. I'm just going to use kubectl. So if I do a kubectl get all in the Postgres namespace, Postgres-demo namespace, I can see everything that's happening, right? I'll see the stateful set being configured. So since we set the replica count as 3 in the UI, PDS UI, it configures that on the backend on my OpenShift cluster, and then it goes through the process of deploying one pod at a time. Since we also asked PDS to enable internal load balancers, load balancer endpoints are assigned to our individual pods in this namespace. If we look at kubectl get PVC in the Postgres-demo namespace, you can also take a look at the different persistent volumes that are being provisioned and mounted and attached to our Postgres pods. Once all the pods are up and running, you can navigate back to the PDS UI. So as you can see, all 3 replicas are 2 out of 2 and in the running state. So let's navigate back, and here you can see that we have our Postgres DemoDB database that's fully up and running and ready to be used by my application. So as a developer, I didn't have to even, if I didn't want to, I didn't have to talk to Kubernetes and learn how these different resources work. This gives me that managed database as a service experience. Now to use this Postgres instance, all I need to do is navigate to the UI and then hit view connection, and I can copy the virtual load balancer endpoint that's available for my Postgres instance, and then copy the credentials. Postgres using PDS uses a simple authentication using username and password. So PDS is the username, and then the password is auto-generated, which can be copied from right here. You can find additional details like the configuration parameters, the name of the database that you defined during deployment, and then the resources. So what were the resource limits and quotas that were set during deployment. If you need to go ahead and, like, in addition to scheduled backups, if you want to take ad hoc backups, you can go ahead and do that as well, and it will initiate a backup operation for you. In addition to backup, other day 2 operation around Postgres is adding more replicas to my database cluster. I can come here and just simply increase the number of database or replicas that I want for my Postgres instance, and PDS will automatically update the stateful set object on the backend and start deploying and provisioning these additional replicas and balance the cluster. So that's how easy it is to use PDS to deploy a Postgres instance on your Red Hat OpenShift cluster. That's it for this demo. Thank you for watching.